Okay, this is 2021 FRQ number 4, still on the non-calculator function, non-calculator section. All right, so it says let f be a continuous function defined on a closed interval between -4 and 6. The graph of f consisting of 4 line segments shown above. Let g be a function defined by g of x equals the integral from 0 to x f of t dt. So we discussed this earlier in our review, but I'm going to say this again. So if g of x is defined as the integral 0 to x f of t dt, then that means you're looking at the area under the curve between the x-axis and f, right? So area between the x-axis and the function f. If I'm asking you to look for g prime, that means then take the derivative. So I took the derivative of this side, you take the derivative of that side, that's a fundamental theorem of calculus. That means you're looking at f of x, which means I'm looking at the graph itself, okay? Now, I'm going to take the derivative one more time. If I were to ask you to look at g double prime, I'm looking at f prime of x. This is asking you to look at the slope of f. So remember this relationship where the three different steps of g prime, g double prime, how that's related to this picture, okay? All right, so on what open interval is the graph of g concave up? Give a reason for your answer. So which one of these give us concavity? The second derivative. So in part A, we're really looking for when g prime of x is greater than 0, right? Because it's concaving up. So if I'm looking for g prime, double prime of x, I'm really looking at my relationship there. I'm really looking for f prime of x greater than 0, which means when is my slope positive? So look at this graph. The slope is positive here in this interval and in this interval. The slope is positive between -4 to -2, and then again from 2 to 6. And that's it. That's all you need to say, okay? All right, move on to the next piece, part B. Let P be the function defined by P of x equals g times f of x. Find P prime of 3. Okay, so this is product rule. Be careful. So P of x equals g of x times f of x. First thing, I'm going to take the derivative. Right, so derivative says P prime of x equals taking the derivative of the first times the original of the second plus keeping the original first, now times the derivative of the second. Okay, now I put in 3. So P prime of 3 equals g prime of 3, f of 3 plus g of 3, f prime of, 3. Okay, g prime of 3. Okay, so g prime of 3, if I look at this relationship over here, to the right-hand side here, g prime means I'm looking at f up. So I'm looking at f of 3. So f of 3, the value of 3 on this graph is -3. And then next one is f of 3 again, so it's -3 again, -3, okay? And then plus g of 3. Okay, so g of 3, if I look at my definition here, g of 3 says I want, and I'm going to work it out right here, g of 3 means the integral from 0 to 3 of f of t dt. That means I'm looking at the graph, the area between the curve, right, this is my curve, this is my line. Sorry, I shouldn't do that. I should clean it up. I'm looking for the curve, I see my function, between 0 to 3 and the x-axis. So I'm looking for this area here and this area here. That's g of 3. Okay, so I'm going to work that out on the right-hand side here so you can see how I get my values, okay? So the first one is a triangle, positive triangle. So that's going to be 1/2 base of 1 times the height of 4. And then the next one is a triangle and a trapezoid. So you actually could do this instead. You can look at this and say, well, this first piece, this first triangle will cancel out this triangle because they're exactly the same, but one's positive, one's negative. So that's gone. So I really just need to figure out that trapezoid that's in the denominator, that's below the x-axis. So this is 1/2. Base 1, base 2 are my parallel sides. So my base 1, base 2 are separately 4 and 3. And then my height is 1 here, so 1. So that's -7/2 because it's a denominator, right? So that is my g of 3, -7/2. And last but not least, f prime of 3. Okay, f prime of 3 means the slope at 3. So I'm going to look at this graph and say, all right, what is the slope at 3? Here's my 3, and it's on a linear function because it says it's a linear function, so a straight line. I can just use slope and see that that slope is 1. So here's my 1. So I get -9 minus 7/3. 7, so if I combine these as fractions, I get negative, oh, sorry, 7 over 2. I'm like, this is a weird number. 7 over 2, 7 over 2. Okay, one more time. Because negative 7 over 2. Right, so negative 9 minus 7 over 2. So 9 times 2 is 18 plus 7, 25. So negative 25 over 2. So just double checking my work here. Oh, I apologize. This is a positive 9. No wonder. I'm like, my numbers are getting a little bit wonky. Okay, sorry. Let me try this one more time. I had negative 3 times negative 3, so it's a positive 9. 9 minus 7 over 2. So it's 18 minus 7. That's 11 over 2. You can leave that as 11 over 2 or 5.5. Either way is okay. Okay. All right, I'm going to erase this because this was my work for part B and see if I can squeeze part C in here or like it. Find a limit as x approaches 2 of g of x, x squared minus 2x. So first thing with limits, I always try to plug it in and see if I get an answer, right? So limit as x approaches 2, that's g of 2 over 2 squared is 4 minus 4. Okay, I'm getting 0. What is g of 2? Well, again, based on this relationship up here, g of 2 equals 0 to 2 f of t dt. So I'm looking for the area, right? I'm looking for the area from 0 to 2 between the x-axis, and so it's this area right here, which we previously discussed is 0 because the positive and negative cancel each other out. So I get 0 over 0, right? Oh, 0 over 0, that is indeterminate form. Remember, that is going to be using L'Hopital's because that doesn't work. So L'Hopital says you need to take the derivative of the top and the derivative of the bottom. So that means limit as x approaches 2. Now you have g prime of x on top. The bottom becomes 2x minus 2. Okay, so then what is g prime of 2 versus 4 minus 2? Well, g prime of 2, if I look at the relationship again, g prime of 2 means I'm looking at the graph, the function, and what is the value of 2 of that function? Well, the value of 2 is negative 4. So I get negative 4 over 2. My limit is going to be negative 2 for this problem. Okay, and so hold on a second. Yes, that's right. Okay. Last one, find the average rate of change of g on the interval between negative 2 to 4. Does the mean value theorem guarantee a value c between negative 4 and 2 for which g prime c is equal to this average rate of change? Justify your answer. All right, so average rate of change is slope. So I'm going to do my work right up here. So I have some space here. So I'm going to look at the interval between negative 4 to 2. So that means I'm looking for g of 2 minus g of negative 4 over 2 minus a negative 4. Okay, so what is g of 2? We already defined g of 2 in the previous problem. G of 2 is 0. Okay, and that bottom is 6. What's g of negative 4? Well, g of negative 4 means I am looking, and this is going to be a little bit backwards. So g of negative 4 is equal to the integral being 0 to negative 4 of f of t dt. Now that's a wrong interval, so I'm going to put a negative in front. So negative 4 to 0, f of t dt. So from negative 4 to 0, you can see it is going to be from negative 4 to 0 is going to be this area right here that is consisting of a triangle and a trapezoid. Okay, all right, so that makes it easier to deal with. So I'm going to zoom out just a bit. Oops, sorry, zoom out just a bit so I can see the picture and answer my question. All right, so it's going to be negative. Okay, first thing is a triangle, 1/2 base times height. And the second one's a trapezoid, 1/2 base 1 is going to be 6, base 2 is 4, height is going to be 2. Okay, so that gives me negative 6 plus 10, which gives me negative 16. So that's negative 16. Okay, so that cleans up to be 16 over 6, which is 8 over 3. Okay, so now, does mean value theorem guarantee that? So you have to look at your function. Mean value theorem needs your function to be continuous and differentiable, right? So it does say that it is continuous, right? It is continuous here. And is it differentiable? Well, g, so this is going backwards. You're looking at g, right? So the function of g, is it differentiable? Well, I'm looking at the derivative of g, so it's f of x. F of x is defined in this entire interval because f is this picture f is defined. That means that your derivative does exist for g of x in this entire interval. If the derivative does exist, therefore it is continuous. So you already satisfied the two conditions of mean value theorem. So I'm going to explain this one more time, writing it down. G of x, g prime equals f of the graph of f, right? So f exists. Therefore, that implies g is differentiable and continuous. So MVT conditions satisfied. Therefore, is it guaranteed? Yes. There exists a C such that f g prime c is going to equal to this average value, 8/3. Okay? All right, that's it.